Now we will see how to implement this two-opt move inside the Java language. As always, the source code is available from this URL. I introduce first an abstract class, TSP local search, and we have inside this class our representation of a tour, which is inside an integer array, and you need to read the tour from left to right. So first you visit 0, then 1, then 2, then 3, and so on. This is the way I initialize this array, okay, with a permutation. And as you can see, the array is not of size n, but n plus 1, because I come back to the city 0 at the end of the circuit. We have two helper methods that will allow you to compute, to save the tour, to back up the current tour inside what we call the tour that is saved, tour saved. Okay, this will simply dump the array here of tour inside the tour saved array, and we can restore it in the opposite direction as well. We have the abstract iteration method that is supposed to do one iteration of the local search move. So it can be, for instance, two-opt, and we will specialize this method for the two-opt move. And then the optimized method is simply a loop that will do the iteration method that is assumed to return true if it was able to improve the tour. And we will continue this iteration to call this iteration method until it cannot be improved anymore. That's for the abstract class. So now let's specialize it for the two-opt move. For that, we will first introduce a helper method, delta two-opt. Okay, that one is supposed to compute the difference on the total tour length if you would apply the two-opt between the left and the right position, right? So it means concretely that you will break two edges. So you will break these two edges, and you will remove this total length. Okay, that's what I'm doing here. I'm removing the purple, removing the red one, and then I add the brown and I add the green one that I have here, right? So you have two edges that you need to remove and two that you need to add. You can retrieve them here because in your circuit representation, if you remember, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 7, yes, 8, 9, 10, and 11, and then back 0. Okay, if you break it after 0, 1, so you will break it here. Okay, you will break it here, and then you will break also the tour after just after visiting 4. Okay, so you will also break that one. What you will do is that you will remove these two edges, right? And so that's exactly what you are doing here. The time complexity to get the delta, okay, right, it's constant time, right? It's because you need to do exactly 4 very basic instructions that just consist in querying the distance metric that you have. And the distance metric, it was also stored here as a matrix, a two-dimensional array in Java. And it's symmetrical, so we don't need to do anything for this part because we know that even if we would flip the length here, it won't change anything because the distance metric that we have here, this one, is symmetric. Okay, so then we have the two-opt move that will actually implement the change of what we want to do. But in that case, you need to flip the sub-circuit here, okay, right? So if we break here the sub-array, so we break it between 0 and 1 and between 4 and 5, we need to flip the sub-array and we need to reverse it. So instead of 1, 2, 3, 4, we have 4, 3, 2, 1 after the two-opt move that will break just after the edge between 0 and the next one and between 4 and the next one. Okay, that's the two arguments. Of course, and this is what we do here, right? We are flipping the array. So this is what we do here. We would just flip here this subarray from left plus 1 until right. And the time complexity to do that is order of n, because in the worst case, the difference of the position left and right might be n, the total number of cities in your tour. Then one iteration just consists in discovering the best two-opt move. So we will try to discover every left and right combinations okay? And we try to see which one is the best one, okay? The best delta 2 opt. And so for every left position, for every right position, we query the delta 2 opt method that we have introduced before. So if you remember, that line can be executed in order of 1. If it's improving the best delta, then you store the position of the left and the right that you have here, okay? So overall, this loop will have complexity order n square, right? Because you have a double for loop and each of them is up to n. And then you do the 2 opt move, and that one is also order of n. Okay, so overall, one iteration is order of n square.